In order to understand GPG and SUSE Linux Enterprise, the GNU Privacy Guard tools, let's talk about what GPG is, and then let's create and manage GPG keys and what you need to do in order to do that. We're going to talk about that. And then we're going to talk about distribution of those keys to make sure that, of course, we never send out the wrong key and expose ourselves to being impersonated or other functions that could happen if you did this wrong. Let's start with GPG first. GPG keys are used for two primary things. The first one is encryption, like for OpenSSH, as an example. GPG keys can be used within that realm. And then also for signing of things, validating that something came from the person who claimed to have sent it. So making sure that an email comes from the person that says that it came from them. For encryption, it's used to ensure that data can't be viewed except by the intended recipient. And then, of course, also for signing, which we can use to verify the source of data and ensure the data has not been changed. So there's several different use cases. As an example for signing, one of the things that we do is we can validate that an RPM comes from the developer by having the developer have a GPG key and making the public key available so people can say, yes, that definitely came from that person. Or maybe for an entire repository of software can also be validated against a key, such as SUSE. SUSE has their own set of keys, and we can make sure that any software that comes from them, we can validate that any RPM or any repository comes from a reputable source. Now, to kind of frame this, when we start talking about encryption and decryption, we're generally using a pair of keys within this process. The public key and the private key. The public key is accessible by everyone or anyone who wants to have access to it. And the private key is only available to the recipient of the data. So the data is encrypted with the public key that anyone can see, but can only be decrypted by the private key. Okay? So that's typically how it's modeled. We can also do signing of data by taking a digital certificate and timestamp the document. It also validates that the document or anything contained therein has a very specific signature. In other words, it hasn't been changed. Now, if the document is subsequently modified, then the signature will not match what it currently looks like. So creating and verifying signatures uses that public-private key pair in order to function. And the operation differs from encryption and decryption because the signature is created using the private key of the signer, and the signature is verified using the public key. Now think about that. When we were talking about encryption, the data is encrypted with the public key and decrypted with the private key. And in signing, the signature is created using the private key, and then it's validated using the public key. So almost a reversal there. Now, SUSE Linux Enterprise software repositories are signed so that you can be sure that the content came from a trusted source. And it's difficult to deny that you made a digital signature since it would imply your private data has been compromised. So we have to kind of keep in mind that why these pieces are in place is to make sure that we can reliably or within certain reason validate that the data is pristine and pure and has come from a source that we trust, which is the point of signing. Now, if we look inside of software repositories themselves, you can actually see the keys themselves. Now, are these going to be the private keys? Well, of course not. These are going to be the public keys or signatures that point to the private key, not the private key itself. It's just a way for us to say this came from someone that we recognize. So how do we create and manage GPG keys? Well, you need to make sure that GPG is installed. It is installed by default on SUSE Linux in most configurations. And then, of course, GPG itself has its own built-in help system, and you can take a look at what's going on within there. There are also man pages and, of course, many search engines that you can track down things with. We then verify with your legal department before exporting, because there are some ramifications and some legal things that you have to be careful, because it depends on where you're sending things, where it could be a problem. There are certain countries that we're not supposed to send encryption to. We begin by creating a key at the command line. It's very simple. It's gpg -gen-key, and then follow the instructions that are found within. If we have more than one key, and it's not uncommon to do so, you can manage different keys with what are called key rings. This allows you to have multiple keys within a single account, like for a single user, but be able to select the key you want to use for any particular task. It's possible that you're contributing to an open source project with one key, but maybe contributing to SUSE on a different open source project with a different key. And that is totally configurable and capable of being used within SUSE Linux. Here is a way for you to look at the GPG keys that are currently available. If you do a GPG --list -keys, it will give you all of the items that are in there. You can also go to, by default, the .gnu pg directory in a user's home directory and look at what keys are in there as well. So once we've created keys using that keygen function of GPG, how do we actually use those keys? Well, you have to distribute the keys to some extent in order for them to be of any actual use. We can export the key to a file, and if you were going to use them for an RPM, you have to import them in, and each box or each server must have those RPMs or access to the RPM's public key ring. So the public key has to be available anywhere that software is going to be installed. Now, you can go and import them directly onto the machine, or you can put it in a location that is default looked at by RPM functions.